Hey there, CG Math students. So today we're going to go ahead and do notes 3.4, which is working on equivalency and basically every single conversion. So the first section should be pretty easy. We want to convert decimals to percent. So what do we want to do with that? We want to start from the decimal and move 2 times right. That's the same thing as multiplying by 100, right? So start from the decimal once, twice. Make it nice and big, just like I did, but also nice and precise, and then with an arrow at the end. So what do we get? We get 26%. Start from the decimal once, twice. What do we get? We get 52.1%. Once, twice, what do we get? We get 56.2%. Once, twice, 19%. Once, twice, 134%. And once, twice, 116%. Okay, very straightforward. Now, to convert a percent to a decimal, again, start from the end, or if there's a decimal, you want to start from the decimal point. And then you want to move 2 times left. Right? So that's the big key, right? If there is no decimal point, start from the end. If there is, start from the decimal point. So starting from the end, move once, twice, we get 0.89. Starting from the end, move once, twice, we get 0.824. Start from the end, because there is no decimal point, once, twice, we get 0.90 or 0.9, same thing. Don't start from the end here, start from the decimal point, once, twice, get 0.894. The reason why I continue to put arrows on the end of all my moving right, moving left, it just helps me remember which direction I moved. So once, twice, we get 0.971. I was a little bit too big on that one. Once, twice, 0.971. And 26%. Once, twice, 0.26. Okay. So these should be very familiar. It's basically the same thing you've been working with when it comes to your fluency sheets, which you'll have another one tonight. If I have a fraction of 15 over 100, if I have a decimal of 0.15, what percent does that make? Well, 0.15. Move once, twice, that makes 15%. If I have a fraction of 73 over 100, or a percent of 73%, what decimal is that? Well, 73 over 100 is base 10, so I can just say, hey, that's 0.73. Or I could say, all right, 73%, let me move once, twice, that's also 0.73. All right, 39%, I would go first to a decimal, then to a fraction. So 39%, 39%, no decimal points, so start at the end. So I move once, twice, so I get 0.39. And 0.39 as a decimal, you could say is 39 over 100. Why is it that simple? Because that's in the 100 spot, and there's nothing to simplify here. I also just say, hey, percent means per 100. That's why we get 39 over 100. 4 over 100 is 0.04. It is not 0.4. That would be 40 over 100. So again, 40 over 100 equals 0.4. 4 over 100 equals 0.04. Major difference. Okay. The percent, you just take 0.04, move the decimal once, twice to the right, and I get, what do I get? I get 4%. Okay. I'm going to leave this section right here to you. The fractions, since they've left them unsimplified, you can leave your fractions unsimplified. All right, exercise 2, calculating decimals. Express your answers with using bars over the shortest sequence of repeating digits. Basically, we're just calculating repeating decimals. You can ignore the negative signs here. We don't need anything like that. So, what's the mantra? It's bottom. Oops, sorry about that. Mantra is bottom into top, or the denominator into the numerator, decimal, decimal, 0. So it goes in there 4 times, which is 36. get 4 left over, put another 0, bring it on down. 9 goes into 40 4 times, which again is 36. Put a 4 left over, another 0, bring it on down. 9 goes into 40 4 times. And so I'm just going to get 0.44 repeated nonstop. So there's my answer, 0.444. You could also check your reference sheet and see that 4/9 is the same thing. 1/11. So we're going to say 11 into 1, 0.0. Does 11 go into 10? No, it doesn't. So we even start off with a 0. Now add another 0. Does 11 go into 100? Yes, it does. 9 times. We get 99 with 1 left over. Put another 0, bring it on down. Does 11 go into 10? No, it doesn't. So there's another 0. Put another 0, bring it on down. Does 11 go into 100? Yes, it does. 9 times. We get 99 with 1 left over. So this is just going to repeat over and over again. So what's my answer? It's 0.0909. And you can put a repeat sign over the last 09. 1/7 is going to be a little bit more challenging. 7 into 1. Decimal, 0. 7 goes into 10 1 time. With 3 left over. 0, bring it on down. 7 goes into 30 4 times. With 2 left over. 0, bring it on down. 7 goes into 20 2 times. With 6 left over. 0, bring it on down. 7 goes into 60. 8 times. With 4 left over. 7 goes into 40 5 times with 5 left over. And then we notice, all right, 7 goes into 50 7 times with 1 left over. So finally we get back to this 1 left over, and then if I brought another 0 down, it'd be back to the original 10 that I have. So it's 0.14287. This turns out to be repeated. That's a pretty ridiculous one. I don't know if I'd ever ask you that one on a quiz or a test, but it's good to know that there is a way to figure out if a fraction is a repeated decimal like that. Again, ignore the negative, and I want you to do 6 into 5 on this one. So real life application, it says Eric and 4 of his friends are taking a trip across New York State Thruway. They decide to split the cost of tolls equally. If the total cost is 8, then how much does each person have to pay? So Eric and 4 of his friends, that's 5 people, and 5 people want to divide into 8, right? So let's see how much each person has to pay. So decimal, 0. 5 goes into 8 1 time. With 3 left over, there's your 0. Bring it on down. 5 goes into 3 6 times, which is 30. Nothing left over, so each person will have to pay $1, and not 6 cents, but $1.60, right? So 1.6 is the same thing as 1.60, not 1.06, right? So just before leaving the trip, 2 of Eric's friends have a family emergency and cannot go. What is each person's share now? So instead of dividing by 5 now, because 2 of them leave, we're left with, all right, 5 minus 2, we're left with 3 friends to divide $8. So 3 into 8. So 3 goes into 8 2 times, which is 6, with 2 left over. So decimal, 0, bring it on down. 3 goes into 20 6 times, that's 18. 2 left over, decimal, 0. 3 goes into 20, 6 times, that's 18. Decimal, 0. 3 goes into 20, and it's just going to continue to be 6, 6, 6, 6. So each person has to pay $2.66, but really one person's going to have to pay $2.67. So because there's no such, you can't tell the toll cashier, oh, I'll pay you 6, 6, 6, 6, 6 repeated. Not going to work. Chandler tells Aubrey the decimal value of 1/17 is not a repeating one. Should he believe him? You could figure this out by division, but right now I just want you to skip that one. You have 1 BuzzMath level to do today. Please make sure you finish the front side of this notes first, and then go to the BuzzMath level.